All right, let's dive in. Today, we're going to tackle a really key piece of the whole hybrid cloud puzzle, Amazon Route 53 on Outposts. We're going to break down what it is, exactly what problem it was built to solve, and how it can make your local applications feel a whole lot snappier.
Okay, so let's kick things off with a question. Picture this. You're running an application on an AWS Outpost. That's AWS gear, but it's sitting right there in your data center. Now, when that app needs to look up another service by its name, where do you think that DNS query actually goes? The answer might surprise you, and it really gets to the heart of a big challenge.
And that brings us to the core problem here. Latency. A big one. Every single time one of your local apps needs to resolve a name, that little request has to take a surprisingly long journey. Let's actually follow the path it takes.
So first, that query has to leave your local outpost, hop on the network, and travel all the way to the nearest AWS region. We could be talking hundreds, maybe even thousands of miles away. And that's just the first half of the trip.
Because it's not a one-way trip. The answer then has to make that same journey all the way back to you. Now think about that for a second. That round trip adds precious milliseconds of latency to every single DNS query. You could have two machines sitting right next to each other, and their conversation is being routed halfway across the country. That can seriously slow your applications down. So, yeah, that's a problem. And this is exactly why AWS created Route 53 on Outposts. The whole idea is simple. Let's bring the DNS resolution right into your data center and just cut out that painful, slow round trip. It really boils down to two key features.
First up is the resolver cache. The best way to think about this is like having a tiny, super fast library branch right there inside your outpost. Instead of having to travel all the way to the main city library for a book, you just check the local branch first. It caches DNS answers right on your hardware, which means most of the time, queries get answered almost instantly without ever having to leave the building. And second, you get what we can call hybrid connectivity. Think of it as a two-way bridge. It uses these things called inbound and outbound endpoints to seamlessly connect the DNS on your outpost with the DNS servers you already have on-prem. It really makes your entire hybrid network feel like one big, unified system.
Okay, but here's the reality check. It's absolutely crucial to understand that this is not a full-blown copy of Route 53 running in your building. It's a very specialized tool for a very specific job. So let's get real about what it can and, more importantly, what it can't do.
So what's in the box? Well, you get the main event, the resolver, with its awesome local cache, and you get those endpoints for connecting to your on-prem world. But, and this is a big heads up, they're IPv4 only, for now. But what's really telling is what's missing, right? All the fancy stuff like health checks, the DNS firewall, traffic flow, all of that still lives back in the main AWS region. Which, of course, leads to the million-dollar question. What happens if your outpost gets cut off from the cloud? You know, if that internet link goes down. Well, things get interesting. You can't make any config changes, that's for sure. And those regional health checks and failovers, they're not going to work. Your local stuff can still talk to each other, but the DNS answers might be stale. And public websites, they'll only resolve if they happen to already be in the cache. The system limps along, but it's definitely in a degraded state.
All right, so we get the why and the what. Now let's talk about the how. We're just going to do a quick flyby of the setup process.
Step one is pretty straightforward. You got to create the resolver itself. You just pop into the AWS console, head over to the Outpost section in Route 53, pick your outpost, give it a name, and then you choose the size and number of EC2 instances that are going to power this thing, right there on your own hardware. Then you just hit Create. And here is a very important heads up. You're going to want to be patient. I mean, really patient. This isn't a click and it's done kind of thing. We're talking anywhere from half an hour to, well, over 2 hours. So go grab a coffee, maybe lunch. Seriously. Okay, so once that's finally done spinning up, it's time to actually build that bridge we talked about by setting up the endpoints. It's simple. Inbound endpoints let your on-prem network ask the outpost for DNS answers. Outbound endpoints do the reverse. They let the outpost ask your on-prem network for answers. That's what creates that seamless, two-way street for all your DNS traffic.
All right, you've built it, it's up and running, now what? How do you actually manage it and keep an eye on things day to day?
Well, the good news is the console gives you some pretty clear status updates. Creating, deleting, you know what those mean. Operational is your happy place. That's the green light. But the one you really need to keep an eye out for is action needed.
That's basically the system raising its hand and saying, hey, I've got a problem over here and I need you to come fix it. And please, please remember this next part, because it'll save you a headache later. You can't just go in and delete the resolver. Nope. You have to tear down the bridge first. Any inbound or outbound endpoints connected to it, they have to be deleted before you can get rid of the resolver itself. It's a simple rule, but man, it's an easy one to forget and get stuck on. Okay, let's boil this all down. What are the key takeaways? Number one, this is all about reducing latency. You keep DNS local to make your apps faster. Simple as that. 2, it simplifies your hybrid network by creating that seamless DNS bridge. And 3, you have to know its limitations. Understand how it acts when it's disconnected, and remember that the advanced features are still back in the cloud. And really, this whole thing points to a much bigger trend, doesn't it? We're seeing more and more core cloud services move from those massive centralized data centers out to the edge, closer to us. So as the edge keeps getting smarter and more powerful, you have to wonder, what's next? What other cloud services are going to start running right here in our own facilities? It's a pretty interesting future to think about.